Okay, what we're going to do in this vodcast is do a summary of writing formulas and naming compounds. So let's start off with the periodic table and review what we need to know to write formulas and name compounds. First of all, we have our line here which designates between metals and nonmetals. So we have our metals on the left, our nonmetals on the right. We need to know the charges of the column. So we have +1, +2, +3, skip that one, -3, -2, and -1, and we'll skip that one. So when we look at these columns, if I say what's the charge on magnesium, you say +2. If I say what's the charge on phosphorus, you would say -3. What's the charge on fluorine? -1. Okay, so let's write some formulas for some ionic compounds. Alright, we've got calcium and nitrogen. So you see that it's an IDE ending. So when we have a binary compound, in other words, two substances, calcium and nitrogen, and it ends in IDE, that means we have the calcium symbol and the nitrogen symbol. If that were nitrate or nitrite, we would have the polyatomic. But since it's the IDE ending, it's the single element. So the first step is to write the symbols, then write the charges. Calcium is 2+, nitrogen is 3-. Do your crisscross, and then our formula will be Ca3N2. Remember, we're taking that number and writing it as the subscript there. We're taking that number and writing it as the subscript there. So Ca3N2. Lithium oxide, again, IDE ending. Lithium 1+, oxygen 2-. Crisscross, we have Li2O. And remember, when the subscript is 1, we don't write it, it's implied. Okay, magnesium sulfide, again, IDE ending. So magnesium 2+, sulfur 2-. Crisscross, when our subscripts are the same for an ionic compound, we write it in the lowest whole number ratio. So it's MgS. Alright, the next type of ionic compound we have are when we use polyatomics. And remember, polyatomics are when we have groups of atoms with an overall charge. So for example, sulfate is SO4, and the whole thing is treated as its own entity with a 2- charge. So if I were to say magnesium sulfate, you would have the formula, or let's use aluminum sulfate. Al, 3+ charge, sulfate, 2- charge, and again, you're treating that like it's its own entity, so the 3 would go behind, the 2 would go there. So we would have Al2, SO4, 3. These are the common polyatomics that we will use throughout the year. The ones that you need to have memorized: ammonium, nitrite, nitrate, sulfite, sulfate, hydrogen sulfate, or we can call it bisulfate, hydroxide, cyanide, phosphate. You don't have to memorize the two phosphates there. Carbonate, bicarbonate, hypochlorite, chlorite, chlorate, perchlorate, acetate, permanganate, dichromate, and chromate. It's a lot to memorize, but it will make your life a lot easier in chemistry once you memorize those. Okay, so let's do some examples using the polyatomics. Sodium sulfate. So again, you've got the ATE ending, so we have sodium. Sulfate is the polyatomic, SO4 with a 2- charge. So when we crisscross, that 2 goes behind the sodium, so we have Na2SO4. you can include the parentheses there, but when there's no subscript behind it, it's not necessary. Now, when you get better at this, you wouldn't keep the parentheses there, but for now, that would be fine. All right, calcium phosphate, Ca. Phosphate is PO4 with a 3- charge. Calcium is 2+. So when we crisscross, Ca3, the 2 goes behind the phosphate. So now we have to put that phosphate in parentheses. And that's a 4, not a 9. Aluminum hydroxide. Now hydroxide is the exception. It's an IDE ending, but it is a polyatomic with a 1- charge. Aluminum is Al with a 3+ charge, so when you write the formula for that, that 3 has to go behind the hydroxide, so you have to include the parentheses. For some reason, hydroxide seems to be the one that people forget to put the parentheses with, so just take note of that and make sure you include that. Okay, so that does it for the ionic compounds. When we have molecular compounds, that means we have 2 nonmetals bonded together. And when we have 2 nonmetals, we use the prefixes mono, di, tri, tetra, penta, hexa, etc. up to 10. So for example, take 2 common carbon and oxygen compounds. Carbon monoxide, carbon dioxide. The rule of thumb, or the only rule that well, there's a few rules, but the most important rule is when you have a subscript of 1, if it's the first one, we don't say mono. So we don't say monocarbon monoxide, but if it's the second one with a subscript of 1, we do say mono. So carbon monoxide, carbon dioxide, dinitrogen monoxide. Okay, so let's do a couple of examples with that technique. Carbon dioxide, well, we just said there's 2 oxygens, so now remember, the prefix always goes before the compound. So dioxide means 2 oxygens. And also take notice, moleculars end in IDE. Carbon tetrachloride, tetra is 4. Dinitrogen monoxide. Okay, moving on, we will now talk about acids. Acids there's a number of ways to write the formulas and remember the names. A lot of people just simply choose to memorize them. There are a few rules that are handy though. First of all, if it's a binary acid, in other words, hydrogen and one other element, you always say hydro. And I always use HCl as the example, because everybody knows that HCl is hydrochloric acid. So you have hydro, chlor, and then the IC ending, ic acid. So hydrofluoric acid, hydrochloric, hydrobromic, hydroiodic. Now there's always the exception. So here we've got the polyatomic cyanide. So we drop that IDE ending, put the IC ending, hydrocyanic acid. And then you've got hydrosulfuric acid. Now we will rarely use that acid, so the ones to really memorize are those. Okay. The polyatomic acids are a little bit different. As you can see, you've got hydrogen attached to a polyatomic. The rule is if the prefix with the acid ends in an ATE, in other words, that polyatomic is nitrate, the acid gets an IC ending, so nitric acid. Nitrite ends in ITE, the acid gets an OUS ending, so nitrous acid. Sulfate makes sulfuric acid. Sulfite makes sulfurous acid. phosphate makes phosphoric acid, and acetate makes acetic acid. Alright, with ionic compounds, sometimes you have elements that are not in one of the columns. So what you need to do is use Roman numerals, and we talked about this in a previous vodcast. So for example, if you look at the periodic table, you will see, that iron is not in one of the columns. So the question might become, well then how do you know what its charge is? Well, that's where you use your Roman numerals. So we would say, for example, iron 3 or iron 2. And you need to include that in the name. So if we were to say iron 3 oxide, that 3 represents the charge on iron. So Fe3, oxygen's in the 2- column, so Fe2O3. So iron 3 oxide has that formula. The common mistake here is to call it iron 2 because the subscript of 2 follows the iron. That's not the way it works. The 3 represents the charge on the thing it follows, which is iron. So iron 3 is iron with a 3+ charge. So whatever it reacts with is going to dictate what that subscript is. Now you don't need to memorize these because the name of the compound would tell you what it is. In other words, tin 4 oxide would be tin with a 4+ charge. Oxygen is 2-. So when we crisscross here, we would have that. But remember, we want to write it in the lowest whole number ratio, so we would write it like that. Okay, so let's do some examples here. Iron 3 chloride, again, is iron with a 3+ charge. Chloride, 1-. So when we crisscross, FeCl3. Copper 2 nitrate. Now nitrate is NO3 with a 1- charge. So when we crisscross, we have that. And then tin 4 oxide, we just did previously, which would reduce to that. Alright, so let's just go through a little bit of a summary flowchart of how you do naming. Let's say you look at a compound and it's a binary compound. For example, let's put 2 here. Lithium oxide, nitrogen dioxide. Alright, so let's take a look at these two. You've got lithium oxide and nitrogen dioxide. So let's take a look at the first one first. Is it a binary compound? Yes, there's 2 substances present. Is there a metal present? Yes, for the first one. Does the metal form more than one cation? In other words, is lithium in one of those columns that we know the charge? It is, so no, it doesn't form more than one. It's just simply lithium 1+. Use the element name for the cation. So we call that lithium, and then the ending is oxide. On the other hand, here, is there a metal present? No, it's 2 nonmetals, so we're going to use our prefixes. Nitrogen dioxide. If we had, say, copper and oxygen, over here, does the metal form more than one cation? In other words, the metal is copper. It's not in one of those columns, so yes, so now we need to use the Roman numeral to name this. So we want to name this copper something oxide. So what would the charge on copper be here? Well, if it's a 1-to-1 ratio, we know that oxygen is 2- because it is in one of those columns, so copper here would have to be 2+ to maintain that 1-to-1 ratio. So since it's 2+, we're going to put Roman numeral 2 there. So we would call it copper 2 oxide. Okay, let's take a look at another flow chart. This would be if a polyatomic were present. So is it a binary compound? No, there's more than two elements. So we go in this direction. Polyatomic ions present. Yes, there's that polyatomic. Name the compound using your earlier procedures. So we would call this calcium phosphate. All right, let's take a look at one last type, or let's review one last type. These are the variables. In other words, metals that metals that are not in one of those columns that we can tell the charge. And again, this is, does the compound contain type 1 or type 2 cations? Remember, type 1 is simply the one that we know the charge. Type 2 is where we have to use those Roman numerals. And we've gone through a few of those examples. Okay, naming can be kind of confusing, but once you get it, it's very logical and it's easy to follow the steps. The best thing to do for naming is do as much practice as you can.